All right, guys, welcome back again. So, today we are going to be diving straight into univariate visualization. Remember, in our first video here, we talk about the principle and some basic etiquette when you are visualizing your data. I mean, the things you should put into consideration when you are visualizing your data. And why are we even doing all of that? That's what we discussed in the first part of this module. So today we want to look into the univariate visualization, and earlier on I showed you a cheat sheet that shows some certain distributions and the type of variables that we use and even why we use them, or the best use case of those variable and the choice of a graph. So here, the simplest one we'll consider is histogram, because we are looking at the univariate case. So when we say univariate, we mean just a single uh, data, like a single feature or variable in this case. Okay, so Instagram here, we are going to be using different features that we have, which is from the breaks to the label to the axis. So another keynote I want to say here is that we have different ways of visualizing our data in R. We have the base R. Base R means that you don't have to install any package. They're already inside the base of the R programming. So all you need to do is just call them and it's going to work. But we do have some packages that we can also use to customize our plot or our visuals, like the ggplot2 package that has so many amazing features. But of course, for the purpose of this class, we are using the base R. And the reason why we are doing that first is if you properly understand how the base R function works, it is easy for you to integrate any package into your work. So that is why we are doing that. Now let's go into our code chunk. So here we are using data. So it's an inbuilt data set in R called the empty cars, and we are specifying a particular variable called the MPG variable. Okay, so we are assigning that to a variable named X. All of this, by now we understand how this flow works, so we don't have to keep going back and forth. And this par function, we use it to on how we want to display our results. So, and then we are calling the east function, which is in base R, and then we'll call the name of the variable. Then we added some arguments that we want in that plot, like the breaks, what type of break, how do we want to title the main graph, and then what is the variable name that we want to give our X. So we do that, and then we do that again for another visual where we use different break properties that we have. And also we try to change the main title and also the variable X, and we display how we want that. So to make this very simple and easy, we are going to go into our R, and then with that we can show what the result looks like. Okay, so here always remember to clean your code chunk, because that's very always remember to clean your global environment. Now the first thing I will do is I want to understand the empty cars. Go to your F function and type empty cars. Okay, so when you do that, it's going to pop up right here, which is what I'm showing you, and we can even read about the documentation of the data. We have thousands of data sets inbuilt in how that you can use to explore and to understand whatever it is that you are trying to do. So here we are using an already inbuilt data set called the motor trend car road test. And we can see the description. This is a long time data, so it's 1974. Most of us are we were not born, of course. So so this is a very long data. It just explain the kind of road test, car road test, and we can see the type of models. So when we come here, we can see the format of the data. It has 32 observation and it has 11 numeric variables. Okay, so we have what we call the my MPG, which is the mile per US gallon. We have the cylinder, that's the number of cylinder. We have displacement, horsepower, rear axle ratio, weight, and all of that. We have 11 of them. And then we have a proper description of that data and even the source. And we have some basic examples. So this help is like your everyday cheat sheet that you should always go into. Anyway, let's get into our code. So remember, we have 4 panes here, like we always say. And now we can just highlight the variable that we're trying to do for the purpose of Instagram alone, okay? For the purpose of Instagram. So let's run that. So you can see that X in our global environment now has this variable MPG, which is miles per US gallon. And what do you notice about this? This has what? It has a continuous a continuous variable, because we can see we have numbers with decimal, right? So this is a continuous case, okay? So and when we come here and we'll come and check the results, let's see what the results gave us. We have the plots right here. We have two Instagram plots, which is what we specify because we're trying to explore different features in our Instagram function of this R, right? So we can see here the frequency, and we can see the frequency here. That's something we indicated in our in the way we describe the arguments in the function, okay? And then the title for each one of them, we can try to extend this to see it even better, right? Okay, so why did that go off? Let me try to release that. I don't know why that happened. Anyways, let's see. I'm not exporting this. I'm gonna go back and let's try to rerun that and see. Okay, so okay. So these are the two plots that we had. We talk about the first one, and then this is the one where we specify the beam width, right? Okay, so this is just to visualize Instagram. Don't forget, if we go back to our notes and we try to talk about the univariates. So when we say univariate, we can have, let's say, univariate, we can have two classes even though we are dealing with just one variable, right? We can still have a continuous base univariate, and we can have what? The discrete. So when we say continuous, let's say it means that something with decimal. When we say discrete in this case, we can look at the categorical case. Let's say you have different categories. Let's say you have gender, right? Gender has what? Male and female, right? So we can look at several cases. Maybe you look at colors. So when you have those cases, they are in discrete phase. So we can take the continuous in terms of numbers like decimal and all of that as a continuous variable. And for us to visualize that, of the Instagram is one of the plots that we can use to achieve that. Okay. So aside that, and when do we use Instagram? We use it when we have a single continuous variable, whether you have it as ratio or you have it as interval. And when you also need to draw your raw frequency shape, like the modality, you want to see the tails. And we added some tips like the billing. You see the two examples that we had. We added a beam width to one, and then we tried to see what the differences in those two plots. Okay. And another thing we should always avoid is when you're, anyways, we're going to talk about this when we get to the stem and leaf or the dot plot. Okay. So let's move to the next thing. The next thing will be the density curve. The density curve complements the Instagram because the basic feature it has is with the shape and the smoothing. Okay, so in fact, most Instagram plots we usually added the density curve on top of it just to see the shape of the distribution. And so this we use the plot function whereby you call the density. There's a function in R called density, and then you call the name of that variable, and then you put in the title just like we did with Instagram. It also works just like Instagram, except that it works with the shape and the smoothing. And then we can try different bandwidths just to visualize different smoothing techniques or how rough you want the density plot to look like. Okay, so all of this code we already have it in our GitHub resources, so all you need to do is reproduce it to be sure that you understand what we are doing. Okay, so we can also go back to our R and visualize that as well. So the second case here is the density curve, right? All we need to do is what? Just highlight and run. Okay? And when you come here, you can see that. What did it do? We can see the shape of the distribution and we can see how that varies. So this, what we did here is we play with the smoothness or how rough you want it. That's something you can play with, okay? So you can see how the density is indicated. And let me tell you another cheat sheet here. Just come here. Any function, type in density. Okay, type in density. Look at that. Kernel density estimation. You can see this is it follows the same the same argument you can just play around with, maybe based on the purpose you're trying to achieve, or the type of data you are working with, or the type of variable you are selecting. So this is something that I always go back here to, to play around to play with my visual, depending on what I'm trying to achieve. Okay, so that's something you can definitely practice. All right, so I'm going to be making this video very short to make it easy for you guys when you are reading, so that it won't get too bulky and then you get overwhelmed. Okay, so the next thing is, when do we use density? I said it works just like histogram. It works for single continuous variable, and when we're trying to compare shapes across group, like what we had in the example. And also we can control the bandwidth. We can use that to control the smoothness. We can add the legend for overlay. And of course, we should avoid when you have exact count. Just when you have when the exact count is needed, because what density usually does, we just talk about that. So when you're trying to get only the exact count, Instagram is preferable, because Instagram can tell us the frequency of each of our counts depending on the type of data we are working on. So that's something we should also avoid. Now, we can also take a quick look at the stem and leaf. It's just to give us a quick shape and the medians, okay? So it's very simple. The function is stem function. You call the variable, and that's it. All right. So when do we use that? It also work for single continuous, because those three works together, okay? And sample size case, when you have a small or medium sample size, say your sample size is less than or equals to 100, and you just want to shape and keep the actual value visible. All right. So the next thing, I'm going to keep it simple right now, and just because we have a lot of slides for this module and I don't want it to be too bulky. So on our next video, we're going to look at box plots and when do we use them and how is it different from